Exam 4 review, question number 34. Express in terms of sums and differences of logarithms. Simplify if possible. So we have a division of arguments which can turn into log base 5 of x square root of y minus log base 5 of 5z to the third power using the quotient rule. Then notice how I have multiplication of arguments, so I can turn each one of these into a sum of logs. It's going to be logarithm base 5 of x plus logarithm base 5 of square root of y minus, and then I'm going to open brackets here because this minus sign is going to affect whatever comes after. It's going to be log base 5 of 5 plus log base 5 of z to the third power. The next step I'm going to do is to distribute the negative sign inside, so you will have log base 5 of x plus log base 5 of square root of y minus log base 5 of 5 minus log base 5 of z to the third power. Lastly, I will use the power rule in order to bring the powers down. Remember that the radical is going to turn into a fraction power. In this case, it is the second root or the square root, so it's going to turn into x to the 1/2. So I'm just going to do that here. So it's going to be y to 1/2, and using the power rule, that power is going to come down. And remember that log base 5 of 5 is equal to 1. So log base b of b equals to 1. That's another fact. So this is going to be log base 5 of x plus 1/2 log base 5 of y minus 1 minus 3 log base 5 of z. And please put a line in the middle of z to prevent the mixing of the number 2 and the letter z. This is the expanded simplified form of the expression given. The next expression is going to be an extra credit, and if you find the compressed version, so I would like you to compress it into a single logarithm backwards. So I expanded this one, and you're going to compress that expression, and if you do that, you're gonna get 5 points. So you have 20 points so far to earn. Question number 36. Logarithm base 3 of x minus 5 plus logarithm base 3 of x plus 3 equals 2. The first step when solving logarithmic equations is to compress any logarithms into one logarithm. So that's what I'm going to do. Since this is addition, it's going to be compressed by multiplication. So it's going to be log base 3 of x minus 5 times x plus 3 equals 2. Now, since we don't have a log on the other side, the second step, so step number 1, compress. Step number 2, I do not have a log on the other side, so turn this into an exponential form. The exponential form says take the base, raise the base to the answer, and that should give you, make it equal to the argument, and that should give you an equation that you can solve. So 3 to the second power equals x minus 5 times x plus 3. You're going to FOIL. You're going to FOIL this. How do you FOIL? First times first and first times last. And then you're going to take the second inners and then outers. Okay. So you get 9 equals x squared plus 3x minus 5x minus 15. You get 9 equals x squared. 3x minus 5x is negative 2x minus 15. You're going to subtract 9 to turn it into quadratic. You get x squared minus 2x minus 24 equals to 0. If you solve this, If you factor or use quadratic formula, it doesn't matter which method you use, you're going to get x minus 6 and x plus 4, which will lead you to x equals to negative 4 or x is equal to positive 6. We're going to eliminate the first one because it's negative and the answer is the second one. Question number 37. This equation is going to be extra credit. If you solve it, you earn 5 points. Okay. Number 38, a certain radioactive isotope has half-life of approximately 1,150 years. How many years would be required for a given amount of this isotope to decay to 25% of that amount? So half-life is equal to e to the r times 1,150. Basically, we're using a of t equals p naught e to the rt, and the time here is 1,150. The initial amount is unknown, so we're gonna say it's 100% or 100, and then the new amount is 50, which is half of that. Which will lead us to 1/2 equals to e to the r times 1,150. Now we're going to solve for the rate. We're going to find the rate. So we're going to take ln for both sides of the equation. These will cancel together. You will have 1,150r equals that. Now we're going to divide by 1,150. So the rate is ln of 0.5 over 1,150. We found the rate of decay. Now that we found the rate of decay, which is going to be approximately negative 0.000602. That is what R is equivalent to, approximately. We're going to answer the next question. So the next question says, how many years will it take for the amount to decay to 25%? Again, I assumed that P naught is 100% or just 100. And then I assumed that half of that is 50. So a quarter is going to be 25% or 0.25. So if you use 25, use P naught equals to 100. If you use 0.25, just use 1 for P naught. In other words, I am using 25 equals 100 e to the negative 0.000602 t. And I would like to find the time it takes to reach that amount. So if you divide by 100, you will get 0.25 equals e to the negative 0.000602 t. Now, in order to solve, you're going to take ln for both sides. These will cancel. So you will have negative 0.000602 t equals ln of 0.25. Now we're going to solve for t. We're going to divide by the rate, which is negative 0.000602, negative 0.000602. You get t equals to approximately 2,300 years. And that makes sense because half of life is 1,150. So to decay half of that, it's approximately double. Question number 39 is going to be the last extra credit that you can earn. And for each part, you can earn up to 3 points. You need to show all of the work to earn these points.